Okay, so we can start now. Hi, everyone. Welcome to the session. So I'm a software engineer leading various learning-related efforts in Chrome. So today, Kenji, Jeffrey, and I will be talking about packaging the web or web packaging. The name web packaging might tell you something about what we'll be talking about. I think you probably guessed it right, but we've been thinking about this for a while, and finding it out that it has various exciting and interesting aspects, probably more than the name implies. So let us expand our thoughts. So we'll be going through our bigger motivation, and also I'll be talking about some more concrete use cases, and I will be also talking about the specs side things, and then finally we'll talk about implementation status in Chrome. So now Kenji will be talking about why we are excited about this.
All right, so my name is Kenji Baheux. I'm a product manager on the web platform team, and I'm here to talk about something vague but exciting and why it needs web packaging. So the vague but exciting thing is actually something that everyone knows about, which makes my part like even more like kind of like hard to nail. This thing is, the vague but exciting thing is actually what was the first comment that was left by Tim Berners-Lee's boss on his proposal for what became the World Wide Web. So this like vague but exciting graph, my interpretation of it is that the web was meant to support a couple of verbs, like being able to write or refer to documents or even include some documents. And then on the consumer side, being able to run some queries to find interesting, discovering interesting documents, and then engage, read those documents. And then finally, like share and react to create even more documents. So this was in March 1989. And personally, I think if we look at what we have today, this is how I feel it looks like. In green, hopefully it shows up clearly, yeah. In green, this is where there are like already exciting things happening. And in orange, this is where I think there is a lot more opportunities for having exciting things happen. So let's take a look at a few of those. So if you look at include, today on the web, there are very few examples of like include. Most of them are actually ads. Like if you look at an ad, it's actually a document. It is there in an iframe. If you ignore ads and you look at like regular content, we don't have a lot of things that are exciting. So the best thing I could find was something like what Twitter is doing when you have a link. They would do this fancy card where you have like a hero element and then some information about like what the link is about, like a snippet. But if you look at it, it's not so much different than just like a refer, which is like putting a link with some metadata about what the link is about. It's not really including the document itself. And there are good reasons for why today include is not super exciting. The first one is that for privacy reasons, it's probably a good idea to not iframe all the things that are on the stream, because the publisher might be learning something about you that potentially you are interested in this particular topic without having you to navigate to the page. The other thing is, if Twitter were to iframe all the links, the user experience on Twitter would be pretty bad. And the final one is that even if they were to do so, when you want to navigate to that thing, you still have an iframe. You can't navigate to an iframe, so you can't tell who wrote that particular article. It's very hard to reason about like what you are looking at. So what if we could make include exciting? I think in the keynote we talked about privacy-preserving prefetch. There will be a slide explaining more what this is about and how web packaging help on that. Ojan kind of like alluded to potentially something like very early stage that would make navigation like much better than what we have today. The tentative name is called portals. I'm not sure we have a session, but if you are interested in learning more about what this is about, come talk to me, and maybe we can like fetch a room and expose more details about what we are thinking about. All right, next one is share. So a typical user experience of sharing is you want to share something with a friend via chat. What we have today is like you will, again, send a snapshot, like a screenshot of what the page looks like and then a link. So again, what we have is essentially a fancy version of refer. What if instead we could make that more exciting by actually sharing the thing that you want to share, right? So one use case is like you want to share a web page or a web app. And when you do that, what could happen is that it will work offline. It will be like instant. And it's very different from what you have today, where it's just a link, and then you have to decide whether or not you have to time or the connectivity to go there. So those kind of use cases are super important for the next billion users. But also, if you think about like a regular user, it's much better to have an offline user experience because it means that it will be instant, right? There is no page load whatsoever. So it's good in general. All right. So now if we take a step back and we think about what is fundamentally like making those include share and discover, I didn't talk about that one, kind of like not too exciting. I looked around and I found this, one of the World Wide Web key principle was about decentralization. So they have a couple of things like no permission is needed from a central authority to post anything on the web. The other one is there is no central controlling node, no single point of failure. And the last one is all of that implies freedom from censorship and surveillance. Personally, I would add a fourth one that goes with the first one, because it's one thing to be able to post anything on the web, but if you can't read it, it's kind of pointless. And I think if you look at what happened today in recent years, I think we are doing pretty bad on all of those. It's very easy to not being able to post something on the web because maybe the CDN was threatened by different people to take your content offline, for instance, or not being able to read something if you are in a specific country with like harsh rule about what is okay to be on the web or not. I believe that this is a key problem, and this is caused by the fact that on the web, distribute is not a verb. If you look at how the content is made available, it is hosted. And that in itself works well for refer and query, but it's also a single point of failure. So, and you can try to distribute the content, like take the content, like grab it, like serve it yourself, but then you end up with like weird things like privacy and authenticity issues. All right, to summarize, we think that sign exchange and web packaging are a way to enable distribute to be a verb on the web, which in turn will help for the use cases that are currently not too exciting. Obviously, that's not enough. It's just one piece of the puzzle. And we are looking forward to talk with you guys and girls to find out what else is missing. All right, and with that, we are going to take a look at like concrete use case and exciting use case.
Okay, so I'm going to go through the various use cases that we're trying to satisfy with this whole effort. So the one that enables AMP to use this is we've called Privacy-Preserving Prefetch. The basic idea is that you're on a particular page. It guesses that you might want to click a link to somewhere else, and so it gives you the content at the end of that link ahead of time. But in order to preserve your privacy, in case you, say, didn't want to click the link, it can't actually fetch that from the real target of the link. And so we offer a signed exchange. So it's a HTTP request response pair that is signed by the original author, by the target of the link, but served by the referrer, so that you can actually fetch it without telling anyone you're fetching it, except for people who already know. Second major use case is for emerging markets, or is primarily for emerging markets, but probably useful elsewhere also. So your friend might download an application, and then you might want to install it without using your data plan. And so if the original application is signed with all of the resources that it needs, you can copy that application from your friend, run it in your browser, have a guarantee it came from the original source, and when it runs, it will be able to act same origin with the original source. Once you go back online, it can request same origin resources without going through the CORS dance. There's several more use cases. For instance, if you're my age, you remember the Slashdot Effect. If you're younger, it's called the hug of death on Reddit and other terms elsewhere. If a popular site links to a small site, it can knock it off the internet. With signed exchanges and bundles, the large site can host the content that it's linking to and avoid knocking the small site off the web. CDNs can use this with some, if we solve some privacy problems. If one CDN is using a sub-resource from another CDN, it can push it down over the same connection, assuming it's signed, which has a bunch of networking benefits. If you're sitting somewhere that has blocked your access to a particular website, you can fetch it from somewhere else with a guarantee that it's the original content, and so you can evade censorship. We have to be careful here because censorship evasion and evading legitimate filtering look almost exactly the same to the browser. So we have to be careful to allow one without allowing the other. And finally, a bunch of people think that with bundles that aren't even necessarily signed, just collect up a bunch of resources, we can get some of the benefits of Webpack, Parcel, and that cluster of tools while still letting the browser execute things when they're partially downloaded or avoid deserializing things multiple times or into multiple formats.
Just a personal anecdote on the Slashdot effect. It might sound like a trivial, a kind of niche use case, but if you are in a time of crisis, I experienced a big earthquake in Japan, and sometimes it was very hard to actually access the information that you wanted to know, what is happening right now. And so this has more interesting application as well.
So we're also looking for more use cases for the same collection of technologies. Let us know if you have an extra one. So I'm working on several different specs to define this area. After talking to the IETF for the first time almost a year ago, they suggested dividing it up approximately this way. So we have the first definition is signed exchanges, so a single request-response pair, and that's what's currently being implemented by the loading team in Tokyo. Second will allow you to bundle up a collection of HTTP request-response pairs, some of which are signed. For an offline shared app, all of them would be signed, but you can also imagine in the sharing case, if you go to a site that has not signed its content, you can just download it and bundle it yourself. And then whoever you give it to won't trust the content, but they'll still have it. They can still read what you claim the website said. And finally, so those two specs are on the IETF side, probably. A third spec on the W3C or WhatWG side will define how browsers load those types of content. So we have a document, also an IETF draft, that lists the use cases that I previously described and extracts a bunch of requirements from them. The ones on the slide mostly describe how bundles have to work. For instance, unlike a zip file, they map full requests, including headers, to full responses. Unlike MHTML, they have to be random access. So that if you save something to an SD card, you don't have to scan the whole thing to load it. And there's a whole bunch of other requirements that you can go look at. So the essence of a signed exchange is that if you have a resource that A.com wrote, it signs it, B.com copies the signed resource, and then serves the content to its users. And then the UA shows A.com in the URL bar, trust it as if it came from A.com. So the thing that Alex Russell is excited about is that this decouples the idea of writing content from serving content, which up till now have been tied together. The structure of a signed exchange, it represents a full HTTP exchange. There's an HTTP header that we've defined called signature, which lists a bunch of pieces of data. So it identifies a certificate that vouches for the content. It provides a hash for the lease certificate, so you know nobody's swapped it out. It defines a validity window for the signature, so that once your signed thing is a week old, nobody can downgrade to that version anymore. So if you fix a bug, attackers can't keep using the old version. There's a way to fetch a new signature. So if it hasn't changed but has expired, you can fetch a new signature instead of having to download the whole thing again. And it identifies a header that guards the content. So we had been using the digest header, but that has some problems with implementability. So we're using a new header that lets you validate chunks at a time. And then it signs all of those header, or all of those pieces of data together. There's approximately three ways to transfer these. The signature header can be part of a normal HTTP response. So this is a way to download the signature from its original author. A cross-origin thing can use H2 push to deliver it, or can wrap it up into a new file format, which you can preload or just link to.
Okay, so now, again, me. So now that we have a format, we also need to load the signed exchange. So Jeffrey and I have been going back and forth how loading a signed exchange should look like. We haven't fully nailed down all details, but this is how it could look like. So basically, the client needs to start with fetching the signed exchange itself. We use the term outer here in order to distinguish from the inner thing that's included in signed exchange. So anyway, it starts with fetching the outer signed exchange from where it's served. And again, we use the term physical URL to call the URL where it's served from in order to distinguish it from the logical URL that's linked in the signed exchange. But anyway, this fetch is basically a regular fetch, and this can be cached. And once the client detects that it's signed exchange, it also needs to fetch the certificate chain. The URL is included in the signed exchange, as you've seen in specs format things. So this fetch can be also cached. And then client needs to verify the signature. And once the signature verification is done, the client unwraps the signed exchange and extracts the inner response from the signed exchange, and then makes an internal redirect to the logical URL that's linked in the signed exchange. And after this part, all the browser activities basically related with the logical URL. And so unwrapping the signed exchange also unwraps the inner response headers. And the inner response headers, if that includes linkware prod headers, the client also fetches them. And if this request was for prefetch, we stop there. But otherwise, the client just goes on and can also cache the inner response with its logical URL. The reason we stop before caching, if it was for prefetch, is because we wanted to protect users from leaking their privacy by timing attacks. So we shouldn't just cache the inner response until actually user loads the URL. And at this point, the client just load and render the content of the inner response. So the response is rendered as if it came from logical URL. So that's how it should look like. And all of these requests should basically go through an appropriate service worker. This time might sound a little bit unclear, but we are figuring it out. So, okay. So now that I've talked about concept ideas and the spec side, we can talk about Chrome's implementation updates, our favorite part. So yes, Chrome implements this. Chrome implements signed exchange. So Jeffrey talks that there are roughly 3 ways to transfer the signed exchange. And the Chrome currently implements the new envelope format that's called application/signed exchange, or SXG. And what happens in Chrome is basically the same as what I just described in the spec section. So Chrome fetches the resource from the network or from the HTTP cache. And if the response content type is application/signed exchange, it passes the signed exchange, fetches the certificate, and verifies the signature, and makes a redirect to the inner response. So that's it. But there are some more details you might care about. So currently, Chrome only understands signed exchanges for navigation and the prefetch request only. So no sub-resource, so no support for sub-resources yet. And no service worker integration is done yet, but we are planning to add that. And this is a very implementation detail, but currently this code is implemented at content layer, but we're thinking that this probably needs to be implemented in the network stack. And one good thing we can talk about is that loading a signed exchange could generate several cryptic errors, and we don't have a good way to show that. But a Chrome canary or a dev channels Chrome implements that a loading signed exchange. If Chrome sees any errors there, we can show the error message in DevTools console. This should be helpful if you want to try it. Okay, so let's again see how all these could work in action. So we probably don't need to hide it, but we've kept saying that we want to use this for privacy-preserving prefetching, and we are thinking about using these technologies in places like a search result page. So how this could look like? So if a user searches for something, and the search result page can probably have something like link-rel prefetch tag and also a link tag to the signed exchange. Then when a search result page is shown, Chrome starts prefetching signed exchange, unwraps it, and also recursively prefetched the link-rel preloaded sub-resources. So in an ideal case, when user actually clicks the link, all the resources are already fetched so that the subsequent navigation should be very fast. That's the basic idea. And also, the URL bar should be showing not the signed exchange one, but the logical URL. I mean, the original publisher's URL. Okay, and now today you can actually try this feature out, or enable signed HTTP exchange flag. This slide says that you can try it on Canary, but actually you can also try it on Dev channel today. And actually, if you really want to try this, you also need to generate the signed exchange. This part's a little bit harder than Chrome part, but there's a tool. Unfortunately, there's no documentation, but you can try it out anyway. We're planning to add more documentation. And hopefully, if everything goes well, we want to start origin trial sometime by the end of the year. That's it. So this is still new technology. We really want to hear your question, opinions, comments, anything. Questions?
Hi. What is the status of this feature on other browsers besides Chrome? And one more question. Traditionally, publishers track their visits on their servers. How does the sign exchange deal with that?
Yeah.
I'll take the first one.
So other browsers have not started implementing this. We've gotten mixed responses. Microsoft seemed pretty happy about the idea. Mozilla is very worried. Safari did see it, but has not really engaged. We're hoping that, so going through the standards process, there's talk of having a workshop of publishers to talk about their feelings about it. That's being scheduled through both the IETF and the W3C tag for later this year. And hopefully that'll help convince the Mozilla and Safari that this is something that the world actually needs. To the second question, once you navigate to the resource, it is the publisher's code running. And the distributor can't change that. So while the publisher won't get the fetches to their server, they will be able to run JavaScript and send pings back to their server to record that their site showed.
So yeah, so that means that the usual IETF package would just run. And as you said, the server pings is something you don't get to see anymore. But it's probably fine because like most people actually use third-party analytics package anyway.
So I'm very excited about web packaging because one of the concerns that people have raised on APIs like WebUSB that provide the ability to distribute applications that act as drivers for hardware using web technologies is that if the manufacturer goes under, then they're not able to use the device anymore because the manufacturer's site isn't up. And the idea of there being, of being able to get the full application as an archive and run that on your device, even after the original publisher site may not even exist anymore, is very interesting. But it sounds like between the validity period and the ability for the publisher to sort of retract the signed exchange, there may be opportunity to make that sort of not work quite as well, which also has kind of maybe possibly some like censorship issues. So like, is there, like, what are your thoughts on that? And is it possible for there to be a no, I really want to load this, even if it's like if it's marked as out of date?
Yeah, so you're right that right now you can't use this for archival. Because the signatures expire for security reasons, you can't trust something as its publisher if the publisher has just disappeared, like if more than a week ago. Their archival people have come up and said we'd like to use this, and so like one thing you can do is strip the signatures, and there will probably be a way to tell the browser to just do that. Then it doesn't run as the original origin, so any origin trust goes away, but you should still be able to see the content. And that's actually important for emerging market cases where maybe you just want to save a web page and share it with your friend, and so they can browse the unsigned version of it.
Would it still be considered a secure origin in that case?
No.
Okay, so like the site wouldn't work properly.
So WebUSB would have problems.
Yeah. And as would games that wanted to use like sensors, and like there are lots of things that we're now requiring secure origins. So
yeah.
Or service workers.
Yeah, if you have ideas for ways to get around that without breaking the security guarantees, I would love to hear them.
I'm curious if the signed exchange hasn't been completely downloaded. Can you stream from the in-progress signed exchange?
The question is if we can load the content from.
If the client hasn't finished downloading the signed exchange bundle, can you start streaming in the page as you would if you visited the site?
Yeah, that's the idea. So bundling is not yet done, but for like a single sign exchange case, we can do that. So we can start showing the page while we are downloading the payload content.
Yeah, you get basically a chunk at a time. So you get the header at once, and then signer-defined records.
Hi. You mentioned that it's only implemented for navigation requests right now. How complex would it be to also enable just packages of sub-resources to enable better bundling?
I think that's possible. We just haven't implemented it yet. Shouldn't be that complex. So we actually support that for Prefetch. Prefetch is kind of sub-resource loading. There will be a little bit implementation gotchas, but we think it's doable.
Yeah, I think there was two parts to your question, which was like bundling and like supporting sign exchange for sub-resource. Okay. Maybe the former is like sub-resource sign exchange might not be too much work, but bundling is, I don't know.
Bundling, we don't know. So that depends on how the final spec would look like. We've actually kind of prototyped some of bundling code before, so I think it's doable. Well, I can't guarantee anything.
And guessing the context of your use case, we will welcome feedback from you to define like how can we leverage this new native bundling to provide benefit on top of what currently exists?
Yeah, so I kind of have a document that I shared with Jeffrey, but we should probably make it public at some point, about like how that would look like from a markup perspective. Basically define a package of sub-resources and then have that be correlated with those sub-resources. But yeah, it's just wondering how difficult it would be to actually implement that in the current infrastructure. But
so do we create new problems for certificate validation? Like Cloudflare a few years ago invalidated like 50,000 certs, you know, in one day, right? That kind of thing. Like, you know, offline is a concern because, you know, typically you're talking to a site, you can actually, the site can shut down the certificate if it's, if they're in control of the DNS, right? You know, there's compromise there. What do you do with offline and?
Yeah, so I think you're asking about how we deal with revocation in a signed exchange world. So right now, revocation itself doesn't work. The way that browsers actually handle revocation is by checking stapled OCSP responses, which live for 7 days and then go away. So the way you revoke is by failing to renew a signature. And that's the model that we're using here.
Right, but you have an offline model now, which has a completely different set of problems, right? Because we don't validate, like you don't use OCSP stapling to validate.
So
anyway.
we are requiring that any certificate used for a signed exchange have OCSP stapled to it, have certificate transparency included. And so that's how you deal with certificate revocation. And for that matter, package revocation, because the signatures expire for the same reason. Talk to me again if I didn't manage to answer your question.
Have you considered the use case of packaging like adaptive video streaming media? I didn't see anything that made me think it wouldn't work, but just like think about you know, a video hosted on YouTube or something like that. How would that work?
Yeah, there's two options there. My understanding of how YouTube and Netflix actually work today is that they cut all their videos into a whole bunch of little files and just send all the little files. And a bundle will be random access to each of the little files, and so a video player will just be able to read whichever ones it wants. If there's a need for someone to include the whole big video file but still be able to seek to it in a random access way, it is possible to use a Merkle tree-based integrity system so that you can actually go to a random place within a file and verify that starting at a byte close to that, it's valid. But we're trying to avoid using that unless it's clear that we actually need it.
Hi, have you considered a use case where the publisher may want to put content behind paywalls or authentication walls, and then the user still want to share that content?
We're not directly like in the signed exchanges and bundles. We're not directly supporting DRM-y things, but the publisher has free control of the JavaScript that runs, and so they can certainly have JavaScript obscure the page and insist on being paid. Or even include DRM-like decryption keys in the JavaScript to make it more difficult for the user to just pull out the content. But there's no direct support.
Yeah, the content that they can distribute would be like the free version that you get, like maybe the first paragraph. And if you want to read more, then you could go through their paywall again. So it's up to the publisher how they want to do it.
Okay, we're maybe running out of time. Okay, thanks.
Thanks again.
Thank you.